Hello, everyone. I'm Jan de Vries, your low-code host. Welcome to the session today. I'm joined today by Derek Gardner from CoMotion and Craig Risi from Allen Gray. Now, with his passion for software design and software quality, Craig will share his best practices for testing Mendix applications, including assigning responsibilities as projects scale and test automation approaches. Now, if you have any questions during the session for Craig or for Derek or for me, please put them in the Q&A and we'll get to them at the end of the presentation. And now over to Derek for an introduction on today's agenda.
Hey guys, I'm just going to share my slide with you while I introduce Craig. Right, so I just want to welcome everybody from all over the world. Welcome to Mendix Meetup. We're really excited that you're with us. As Jan said, today we're going to be talking about best practices for testing Mendix apps. It's my job right now to introduce Craig, which I'm going to do. Craig and I actually have quite a long history. We were in primary school together, and at one point we were fierce athletics team competitors. And I remember getting beaten to the line often by Craig. So he's quite a runner, but we're going to get to that now. So Craig works for Allen Gray. So Allen Gray is actually a global financial company based here in Cape Town. And Allen Gray actually contribute quite a lot to the IT community. They're known for quality. And I remember as far back as about 10 years ago, attending talks where Allen Gray had people from the IT department who were talking about how to create quality software. So they definitely know something about quality, which is why we're really excited about having Craig talk to us tonight. So Craig is a QA architect for Allen Gray. He's also a writer. This is just a snapshot from his LinkedIn account. He writes quite regularly and some very good stuff on quality and quite consistently. He doesn't only write for himself on LinkedIn. He's actually, I think he's published as well, but I'll leave that up to him to tell you about it. But he also writes for this site, and I've actually forgotten its name right now. But Craig can tell you what it is. He writes a lot of articles for them, and he also creates board games. So he has his own website, Risi Games. You can check it out. There's some free board games that you can play, and he creates them quite regularly. Craig is also a runner, as I mentioned. So here you can see Craig finishing the Comrades Marathon. He's done it quite a few times. He's done quite a few ultras, and I know he's also run a few marathons around the world. And as I mentioned earlier, he's really hard to beat. Before we actually go into Craig's talk, I'm going to hand over to him now. I just want to plug our next talk. In South Africa, we're going into end of April. It's going to be holidays here, school holidays. So we're not going to organize anything, but I know the community is really active with content that's being created. So there's definitely going to be something up there. But the month after that, the last Thursday of the month in May, we've invited Hardy Yonk to talk about event-based architecture. He's really just going to talk about what it is, how it applies to Mendix. He's going to give some best practices, and then he's going to give us a quick demo of how he uses it in Mendix. So that's going to be useful if you're looking to clean up your architecture in any way, or use it, and obviously use events to do that. Then the talk next week is for you. So just quickly, why are we doing this? CoMotion is a Mendix partner. So we relate to all the things that everybody in this community is going through and when you implement Mendix. We also do Mendix Malt, which is a YouTube channel dedicated to Mendix. So I'd like to invite you guys to check it out. We've actually posted a video just last week or the week before on how to overcome resistance to Mendix. So if you're kind of facing some of that resistance, then this is quite a useful video. Check it out and drop me some comments, because I would love to have a conversation with you if you find it interesting. So lastly, we also write a lot about innovation. We like to see ourselves as an innovation company. CoMotion is at heart an innovation company. We use Mendix to innovate and to provide and to innovate within mainly the financial industry and life insurance industry. So we've got a lot of content on innovation. If you're interested, check that out. And so that is just the introduction. I'm looking forward to what Craig has to say. I think it's really going to be useful. And now I'm going to hand over to him.
Great. Thanks, Derek. Appreciate that introduction. Let me just share my screen. So yeah, thank you. Today we're going to be talking about best practices for Mendix testing. I do want to just, I guess, give a warning up front. I am not a Mendix user. I do not use Mendix from a day-to-day basis, but Derek has given me quite a good sort of introduction in terms of what Mendix is about, and the brief sort of introductions I've seen, I've definitely been able to figure out, how a lot of the best practices that I've been able to apply in my software testing career can definitely apply in the Mendix space as well. And I'll definitely hopefully share a lot of that knowledge and experience in today's talk. But Derek did introduce me, but I thought I would just give a brief introduction about myself as well. As he said, I work for a company called Allen Gray, where my title is a QA architect. And essentially what that means is that it's my responsibility to help us build software that is of a high quality and testable. So it's not something that we just want to focus on from a testing perspective, but we're actually building our software with that in mind. And then I also write for a site called Critical Hit, and then design board games at Risky Games as well, where you can also find a lot of my stuff there. But back to today. I think testing and quality is something we can all relate to. And today, although this is really a talk around testing, you're going to hear me use the word quality a lot. And I think the reason why is because, to me, software testing is really just a means to being able to achieve software quality. And I think the real discussion is really around software quality and the importance of software quality, to us, to all of us, but especially to our users. And I think in particular, many of us could probably relate to what this picture is saying, where it's very easy for things that sometimes seem small in the development space to often, escalate as it goes on and on out to our customers. And we've got to be very kind of careful in the software space where things are getting increasingly more difficult and more complex. And what that just means is it just makes it that that end goal of trying to meet the customer's needs even more critical. And I say customers' needs because customers' needs is not necessarily always that your website looks flashy, is cool and innovative. Sometimes it's really just got to work, and it's got to work within a specific way for them. Got to be performant. And I'll go through some of the aspects of what quality is. But it's very important that we start software and trying to think about what's happening from a customer perspective, what the customer needs to experience, and then work our way backwards from there. Because, as I said, sometimes small things can really have a big impact on the customer. And Allen Gray, with the company that I work with, we're in asset management. We deal with people's money. And, you can't really afford to make a mistake in a lot of what we do. 90% of what we do is really moving people's money around, collecting people's money, investing it in some locations, and then taking it out and moving it to other funds. And that's something where you can't really afford to make mistakes. And so we take quality very seriously. But at the same point in time, we don't want to just focus too much on quality. We still want to be innovative, we still want to be progressive, and we still want to join this modern world of DevOps where we need to deploy into production every single day so that we can still be innovative. So hopefully today, I'll be able to share a lot about how we can deliver quality, but also deliver quality in a way that's fast and timeless. But I think this is a popular diagram, but I thought it's just worth talking through really about the cost of fixing defects. Now, I think all of us know that the cost of fixing defects, once we're kind of in production, is expensive. And I don't just mean from, the amount of effort it's going to take to actually fix the actual defect, but really it's the cost of reputation, to your business, your clients being frustrated, and then overall, I think just that whole cycle of now going all the way back into your dev team has now moved on to something else. Now they've got to come back and now fix something that they thought was working. And so really what you want to try to do is obviously try and bring the cost of defects as close to the design phase as possible. And notice how I said the design phase and not the testing phase, because even though we're talking about testing, quality is really, encompassing the entire software development lifecycle. And I want to talk through some things that will actually help bring it closer to the design phase so that you can save even more time, because even at the testing phase, it's often too late. It's still too expensive. You want to try and catch things as early as possible. And I think, a big factor around that is really the quality triangle. And I think it's important just to mention this because, with this triangle, essentially what it's trying to say is that if you want to achieve high quality, you've got to have a look at time and cost. And the truth is that you cannot achieve high quality while sacrificing either your cost or your speed. So in order to do it, you've really got to be able to, if you want to go and do this quickly, you've got to be prepared to invest in it from a cost perspective. And so, what you really want to try to find the good mix and match between speed and your resources or your cost. And hopefully today will also help identify aspects of that as well. But it's something that you can't compromise. I think most of us should agree that where you want to be is in the bottom right-hand side of that triangle. You want to be in the high quality phase. We all want to value and take value in the software that we deliver to our clients. But it's not that easy to always do that, especially when we do need to still deliver quickly. We still need to keep in mind that customers don't just want the next update to their fix in 2 weeks' time. They need it tomorrow. So we've got to be sensitive to that. And hopefully, again, some of the stuff I'm talking about today helps to achieve that. But I want to start really by talking about quality by design. And again, I think in mentioning quality, it's really about how you go about designing your software. Now, quality is something, for me, that is really a result of deliberate design. It's not something that you can just plan to resolve by testing. You can have the world's greatest testing team by you, but if your software is really badly designed, it's going to be problematic, and no amount of good testing is going to be able to solve that. So really it's about how you design your software first and foremost, thinking about quality in mind, thinking about what your end goal is from a quality perspective and building it as such. I think it's really treating quality as you would any other software design. Just like we're designing software, we go through multiple different phases. You've got to treat the same thing when it comes to your quality. You've got to take it seriously. You've got to think about how are we going to maintain our software? How do we need to be able to build and write our software to be able to make it more testable? And then even just from that testability perspective, and I'll get that into a little bit later when I talk about automation, even the automation side, that's software code that's got to be treated as such. And so you really want to be able to treat your entire aspects of quality like you would any other type of software design. Thirdly, it's everyone's responsibility. It's not just the testers. Everyone needs to step in and do their bit to make quality work. That means the architects need to do the right job in designing the software correctly. That means the devs need to do the right job in terms of the code that they write and the like unit tests that they might write. And the business analysts need to make sure that the requirements they're writing match, what the expectations are of both the team, the technical requirements, and the customer. And so you really want everyone to come on board to make this a success. And really what you want to get to is that quality should never be taken for granted. This is also not something that it's a once you've done this, you've now achieved quality, your software is fine, you can move on. Quality is something you've always got to revisit. We always need to be updating our software. We always need to be going through maintenance and improvements. And so this is something that you should never take for granted. You've always got to be working on it. You've always got to be building towards it. And so it's not something that you should ever decide to take your foot off the pedal. You've always got to be working on your software quality. And again, it's really encompasses everything. So whether you're looking at designing your software code, deploy, your security, your performance, everything really ties into quality, and it really needs to encompass every little thing that you do. And so it's important when we're thinking about software quality that we start thinking about all of the different processes that we're working with and start asking questions of how does this contribute to the quality of my software? And if you can't answer that question, there's a good chance that maybe you're doing something wrong, or maybe you need to revisit your approach to it, whether it be your processes, whether it be your deployment strategy. We need to always be thinking about that when we deploy, how we deploy, and how does our deploying make our software quality better? How does our deployment make our software testing better? And if you start designing your software from all these different phases with that in mind, looking back at the quality or looking into the quality, it really does help when you're starting to think about things, how to do or how to design your software better, or how to do this particular bit of analysis or this particular bit of security better, because we're now thinking about the end goal of quality. But I guess to get into more specifics, I like to think about it as a puzzle. Now, say for instance, I were to ask you, I want you to test a puzzle. Let's take 1,000-piece puzzle. I'm going to give you this puzzle. You've now got to go and test it, make sure that every piece in this box comes together and actually, all 1,000 pieces come together and form that picture on the front. How are you going to do it? Well, the only real way to do it is to open up the box and start building all 1,000 pieces together and be able to get the picture in the front. Something that's quite fun to do. But say I come to you and then say, okay, great, but now I need you to do that 1,000 times. So now you've got to test 1,000 different puzzles, and ensure that each puzzle, what's inside the box, really does add up to the picture in front. How are you going to go do that? I mean, you could try and build the same puzzle 1,000 times, and you might get a little bit quicker at it, by the time you hit your 1,000th puzzle. But that's just going to take too long. It's just not feasible. There's no way you'd be able to test the puzzle in that way. And really, what the only way that you can really test that is by probably saying, okay, instead of trying to test all 1,000 puzzles at the same time, or try and test 1,000 puzzles and how they build together and test them in their entirety, rather break it down and say, okay, I can't build this puzzle 1,000 times, but what I do know is that each individual piece serves a purpose, and each individual piece can be uniquely identified with a different shape, unique color, and by doing that, what I can do is just simply say, okay, well, I want to take this piece, and if all I need to do is then match in each box, make sure that it's got that piece 1,000 times. It might still take a long time to do, but that's a much faster way of doing it. And as we relate that to a software perspective, if you were to think about it from an automation perspective, if you're going to get a robot to automate building a puzzle 1,000 times, it's, again, still going to take a long time, even for a robot to build a puzzle 1,000 times. But if you tell that robot to identify that puzzle piece, 1,000 times across each box, it's going to be able to probably do that quite quickly. And so again, just from a testing, from an automation perspective, it helps if we start breaking down a puzzle, not so much into its bigger picture, but rather into the small specifics. And what that means from a testing perspective is that we really need to start looking at testing smaller. So what I mean by testing smaller, I think a lot of times testers spend their efforts looking end to end at the software. They'll go in, look from logging, go all the way through end to end, how the software works all the way to the end. And sometimes there's nothing wrong with that, but essentially that's just not a very scalable solution. If you want to now automate that, and you want to automate end-to-end tests across your entire software suite, that's going to be quite difficult to achieve. Rather, what you want to do is focus on the smaller aspects, try and break it down as much as possible. At Allen Gray, we use microservices. So we've got over 200 microservices, with each API doing something different, with each sort of micro front end doing something different. And within that, it becomes a lot easier to test that piece and know that those pieces all work quite well. But I think even just from a, if you don't want to talk about a specific microservice, if you're not using microservice architecture, I think even with bigger systems, it's still something that you can do. Whereas instead of just focusing on the end-to-end functionality, rather focus on each individual module and focus on each individual function. And then what you can do is you can test each function really well. Because if you know that if, let's say, a particular feature has all these 10 functions that have got to work together, you know that if every single function from an input and output has been thoroughly tested, yes, you'll still need to test all of them working together, but the likelihood of you needing to test every single permutation is no longer needed. Essentially, what you want to do is try and test, each function and make sure that that's well tested. I think another way of maybe explaining it is through this testing triangle: unit, component, integration, end-to-end, and exploratory. Typically, in my experience, I've seen a lot of testers tend to spend too much of their time at the top end of the triangle, focusing on the exploratory tests and the end-to-end tests. Whereas what they should actually do is spend their time focusing on the unit tests. Most companies will maybe have the devs write the unit test, but if you think about it, the devs, their job is to write code. And I've been a dev, I know what it's like. When you have a dev mindset, it's very different from having a tester mindset where you're thinking about things a little bit more critically. And really what you want to do is have your testers, the people that are really thinking about quality and testing the most, come in and design, and have a look at the unit test and what's going on. Because if you can go into each individual part of your code and make sure that that's well tested, you can have a really good way of ensuring that further up the triangle, you're not going to need to do as much effort. Let me give an example by maybe taking something simple like a login screen. So you can have a login screen, and most testers will go, okay, here's a login screen. They'll start testing it by going through all the different permutations, how many different types of usernames you can put in, how many different types of passwords, any other options that they need to click the button, resetting password. There's all these things that you can do, and there is countless number of permutations that you could end-to-end test. But if you know from a UI perspective that, you know, that username and that password, when you click the login button, it goes to some API that then goes and validates it. You don't need to actually have the login screen there at all. Rather go into the actual modules, which then handle the validation of the usernames and the passwords. And you can write a whole bunch of unit tests around them so that you know each individual thing, you know, there's then inputted into this particular function or this particular API, then caters for all those permutations. So when it comes to you now needing to actually test something from an end-to-end perspective, you're no longer testing all the permutations. All you want to do is make sure, do the different elements speak to each other. But from a unit test perspective, you know, closer to the code, you've made sure that everything works well. And I think in order to do that, you know, it really takes, firstly, I think knowing your specifications quite well. So if you're going to break a big piece of software now into smaller chunks, you can't just do that by understanding how each individual part is supposed to work together. So if you've got, you know, an application with multiple microservices, multiple APIs, or even just multiple functions of code, you've got to know why this piece of code exists. What's its inputs and outputs? What needs to go in this code? How is it supposed to respond to this code? And how should it then output that? And if you can understand that, you can then start writing tests quite easily for knowing, okay, I've got this function. If I write this test, I get this output. And then you do that across for each individual function. But you've got to understand what's going on quite well. You've got to understand your requirements quite well to be able to do that. I think you've then got to also know your dependencies, because now that we're testing our software in individual smaller pieces, that also means that we don't necessarily now test them in a chain. But if you know your dependencies and you know what functions you're dependent on and what functions are dependent on you, you can ensure that you cater for that in your testing of your particular function that you're working on, function, microservice, whatever it might be. And you can test for all those permutations when you're doing your testing to ensure that what you're testing here in an isolated way doesn't actually impact either side. And then you can simply just make those changes to that function independently, knowing it's not going to break either side. Test where your logic happens. Like I said, we've got to get as close to the code as possible. So you want to be able to test specifically where your logic happens in your code. So unit testing as much as possible. There's no point writing these long, elaborate end-to-end tests through the UI when all the logic is happening deep inside the code. Rather have your test, write your test right there and then. It just makes a lot more sense. You catch it faster. You can also, if you're clever, design your tests faster so that you can actually design them while the dev is still writing their code, and then they'll write the code to pass the tests, guaranteed to work in the bigger set if you understand what you're doing. It takes designing right. I think a lot of times we don't do this because we actually haven't thought about our software design in this way. We're thinking about our software design looking at the bigger piece of the puzzle and what to go to do, and we understand how this thing works together, but we're not breaking down each individual part of this application detail, you know, in enough detail to really test it better and understand it better. And so you've got to be able to design your software in a way that it can be very modular, that it can work independently and consist of a lot of smaller moving parts rather than one big cog that's now trying to turn. And I think a key thing is at the end, it's a lot easier to automate when your inputs and outputs are a lot smaller and simpler. But I'll talk a bit more on that later. So what makes a good test? I think it's got to be specific. It needs to be clear exactly why a test exists. I've seen a lot of people go in and they write these tests, and I think devs are often most guilty of this in their unit tests, but they'll write one unit test and try and assert 50 things on it. And then that test fails. And so now which of the 50 things failed the test and why? If maybe, for instance, it failed on the very first assert and the whole test fails and the rest doesn't execute, you actually have got no clue that the other 49 tests, you know, are they working or not? So it's got to be specific. Each test needs to test a specific thing. So rather keep your tests small and simple. It's got to be clear. I always think that commenting and documentation of code is almost as important as the code itself, but you want everything to be very clear to follow within your tests. It needs to be traceable. Every piece of code has got to exist for a reason. And I think we often get into these points where we've got complicated code bases that are not well maintained or difficult to maintain because there's so much code in it that we don't know why it exists. Every code should point to some technical requirement, some specification, and some test linking to it. And everything should link to each other. And if you have everything traceable, you should know exactly why the test exists in the first place. You should know exactly why the code exists in the first place and exactly what code it's trying to test. And this can be done if we're using the right tools to be able to ensure that we have this traceability. It's got to be self-contained. Every test should be able to run independently of each other. Like I mentioned in the previous slide, tests need to work independently of each other. You don't want to run a test that's now dependent on other tests. And then if that aforementioned tests in front of it fail, now you're stuck with a whole bunch of tests that haven't been able to execute. And what that just means is that you're now going to work hard to fix the test that's failed, but you might be wasting effort because there's a whole bunch of other tests that would have failed as well had they had the chance to run. So try and design your tests as independently as possible. Got to be segregated. Your testing config needs to be in separate ways. And so when you're testing, your actual test case that you're working on and the config of your software should not be built into the same test case. I'll get into a little bit more of that later, I guess more in the automation side of things, but it's got to be separated. It's got to be prioritized. You've got to know which test is more important. You can't just test everything. Certain tests are more important than others, and you should be able to get to a point where you know that, and those are the first tests that you will execute. There's no point testing this feature in detail when the very next feature that you're now going to test is now going to break the entire software. Rather test everything that you know can break the software first before you start going into detail. And then lastly, it's got to be predictable. I think testing gets frustrated when we feel like our results are inconsistent and we're not so sure, and we're starting to doubt, does our automation framework work? Is our test strong? Tests should always be the same, and you should always expect consistent outcomes as a result of that. And that's difficult to do in a big end-to-end test suite, but that's very easy to do when you're breaking it down into a functional aspect, when you've got a small function where the inputs and outputs are clear. And that's what you want your test to do. It's got to be predictable to give you reliable outcomes. But I think, thinking that in mind and thinking about how do we design tests and how do we build quality software, I think we have to tie in automation into it. There's no point us delivering high quality software if we can't produce it very quickly. And automation helps us to be able to deliver our software a lot faster. I do want to, start off by, I think, first just question a myth. And I think a lot of the reasons why people don't understand automation is a lot of businesses think that automation is something you can build your automation into your code and then move on. And what it's going to do is it's going to take a lot of work, we're going to automate it, and then we can ramp our team down, let our testers go, and everything's just going to work. The truth is automation doesn't work that way. Automation is writing code just like anything else. It takes a lot of effort. It takes a team to put together, but it has a life cycle that keeps growing. Tests need to be maintained. Tests need to be worked on. Most tests will often, depend on certain libraries, and those libraries might change and might need to get updates. And then the underlying code that's being tested also needs to go to changes and revisions, and the automation script's got to be changed. And then over time, your software architecture might change, and then your tests have got to adapt to that. So your automation's got to move forward with that. And typically what you find is that with true automation and the return on investment, it's not so much that you now expect to start having less testers, but typically automation is not about using less testers, and it's not about saving you money. It's really about increasing your productivity, and that's all automation does. It's allowing you to be able to achieve that same level of quality you want, just faster. And in this return on investment graph that I've provided, you'll notice that the actual effort line, it starts to flatten out the amount of effort you put into any particular automation suite, but it doesn't go down. At no point in time do you get to a point where you're like, okay, everything's automated, we can now have less testers and spend less effort on testing. Quality doesn't work that way. If the moment you start taking it for granted, you're going to have bugs. The moment you're going to stop maintaining your automation suite, it's going to become flaky, frustrate you, and you're going to just throw it out the window again. So that's not something you want to do. Automation's purpose is purely to increase your productivity. So don't think that through automation you're going to save money, and that through automation you are going to need less testers. All automation is going to do is allow you to actually just be more productive as a team, and that should be your end goal of what automation does. How does a typical automation pipeline work with? And there are multiple ways of doing this. This is typically how I've done it in my space, but I also find that this is probably the easiest way to do it if you want your automation to run reliably, is to have your test running in some sort of CI pipeline, where what it does is it breaks down the code into small places. So when your code is deployed, it takes the code, it takes the test cases that are relative to that code. And when I say the code, if you're just making changes to 10, 15 files, just bring that in, bring your test cases, bring your test data and your database in, put that together, and then run through that suite together. What you want to do is make sure that that runs well. So your automation CI suite should run quite detailed on your code, with a lot of tests that are now automating that code and testing that code before it then goes through, and then you pass it on to the next system. And if it's not meeting the criteria, something's failing, you got to go and fix your code. But you're only fixing that piece of code because you've only been testing and automating on a smaller piece of code. So you're executing small pieces of code in your CI pipelines, and you're only moving on to something bigger once all that code passed. Then you can move it on to a bigger pipeline, and then eventually into another system, and then eventually into prod. And I think one of the reasons why people have tried automation and it doesn't work, I think it's also sometimes because, again, that they don't understand how automation works, and it's a long-term plan. And I'm going to specifically talk to, I think, 4 things. But I think an important thing for me that's going to put out there is skills. In the bottom right, I think skills in it is an important gap that I think a lot of people don't understand. If you want to make automation right, you really got to have the right skills in place. And I think that's really something which I want to stress up front. You need testers who are able to understand code, understand how things work with regards to debugging, be able to debug what's going on with the software, and being able to dive deeper into that. And those are skills that I think we often don't foster enough in the testing space, and we often then counterintuitively, those people that are now trained up and in the dev space and know how to code aren't then taught enough about testing. And so we kind of stuck in this impasse where the skills needed to build high quality software are not there. And one of my biggest frustrations is universities, when I studied, you do a 3-4 year degree in computer science, and I think we spent like maybe 1 or 2 lectures actually talking about software testing, and yet it's what I've dedicated my most of my career to. And probably about 20 to 25% of people in the software development space are often involved in some in a testing capacity in some way. That's a lot of skills for something that universities don't teach. So it's definitely something that's it's a big gap. But there's also other things just around redundancy. I think there's a lot of times when you have your testers, they tackle automation separately to the devs, and then what happens is that the devs they build their stuff, they write a whole bunch of unit tests. Now your testers are coming in, they want to automate and do everything, but all they end up doing is writing the same tests that the devs done, rather than working with the devs on their unit tests. So when it comes to them automating something a little bit higher up, they only need to do a couple of lightweight tests. And so that there's a lot of redundancy. I think there's a lot of inconsistency with different standards. And then the last thing, I think, really just the understanding of iterative development. Automation is not a one and done deal. It's something you've got to constantly invest in along the way. I guess just to give another example of how automation pipelines work, really what you want to do, and you want to build your software, you want to take it then from there to a point where it's acceptance tested. So what I mean by acceptance tested is the software actually works and does what it's supposed to. Whereas at the same point in time, you can then also verification, which is to test the connectivity. What I mean by connectivity is you want to make sure that the different parts of it speak to each other. So say, for instance, you're working with a microservices architecture like the one I work with. We want to test each individual API, and we can automate each individual API independently, but we will need to test that it can communicate with mocked versions of those other dependencies. And so there's a level of connectivity we need to test before we actually then go and deploy. And we can test and automate all these things in their own Docker containers before we even deploy it into some form of bigger environment, where we then go and we actually test its deployment and actually make sure it actually can deploy into a production-like environment. Then we can also have some synthetics which can monitor and ensure that our system's operating successfully, with then ending in which I call Chaos Monkey, which is even automated exploratory testing. So we've gotten to a point where we can write, we've written a whole bunch of queries which go and pull a whole bunch of random automated data from our databases, because we've kind of learned a little bit about how our clients behave, and it pulls similar type of stuff to what our clients are doing. and then tries to do that while throwing other random elements in, and then to see if our system can actually successfully survive through that as well. So that's again something you can also automate when you understand all these things. What makes a good automation framework? It's got to be robust. It needs to be able to handle when something goes wrong. There's no point having automation scripts that fail all the time because your code is not behaving as expected. Your code's not always going to behave right. Your environments are going to fall over, and it needs to be able to be robust enough to be able to deal with that predictability. Okay, great, something fell over, I'm going to start again and continue testing, because if it's going to fall over at the slightest failure, you're missing out on a lot of testing that can still happen. It's got to be modular, which is something we shared before. It's got to be able to, each test should be able to run independently of each other. Tool agnostic, I think is an important one. I don't want to tie myself to specific testing tools, and there's a lot of great testing tools out there and they're fantastic, but a big mistake a lot of companies make is they invest in this testing tool that achieves a lot of great things. They go and they integrate themselves into it, all of its different sort of features, and that it comes with, and then they even go and write it in its own sort of language, because some of these testing tools come with their own language. The problem with that is testing tools are always going to be changing. They might eventually move on to something different. They might change, or maybe there's something better that comes out and you want to move on to that, but now you can't because you're too tied into the testing tool itself. And I know that Mendix, for instance, has got a variety of different testing tools that you can work with. And there's nothing wrong with having those testing tools, but what you don't want to do is rely on them. Rather, what's better is to build your automation suite to be able to rather run in a way that you can control it, you can control its output, but that you completely untie yourself from the tool that you're working with. And so it becomes completely tool agnostic, and you can go and rather, and I've had this before in my company where we needed to change from one tool to another because a better tool came out, and we're like, we'd rather be using, be on the cutting edge of software. So when new tools come out, we want to play with the big boys. We want to try new things. We always want to be using the next best software, so that our software is always on the latest tech. But in order to do that, you can't now constantly rewrite your tests all the time. So what we do is our tests are written in a framework which we've designed, something that we can control, and rather it's just a matter of writing a module that interacts with the tool or sends something to the tool. The tool can still go and do its thing, but our tests don't need to be rewritten every single time. So it's something we can control. It's got to be reusable. It's got to be able to work all the time without fail. And when it does fail, it needs to be a legitimate error. And it's got to be able to adaptable. Software is changing all the time. And if your tests are too focused around the whole big chunks of software and not modular small parts of the software, it's not going to be very adaptable to change. So you want to be able to ensure that as your software changes, your tests can change with it, and it doesn't require too much maintenance to keep your tests going. But saying all those things, to achieve good test automation is not easy. I think our business requirements are constantly changing, and we've got to understand that often it can be working towards a moving target where we thought something worked this way, but now the business is changing those things. And so we've got to be prepared to understand that sometimes that's going to happen, and we need to be prepared or flexible, I guess, just to be able to work with these things, and I guess just understand that that's going to happen. There's going to be a lot of change. Same on the technical side of things. We might start off our software thinking it's going to work a certain way. Over time, it starts to change in terms of our needs of it. We might need to change our architecture to better scale. We might need to redesign something to better work for a specific use case. And our technical requirements are constantly changing. That's something that needs to be factored in. And as the underlying software changes, so the test automation is going to be changed. So again, we've got to be treating it like every other piece of software. As our software changes, we're going to be maintaining our automation suite. Infrastructure outages, things go wrong, things can go down. That can always be quite frustrating. Resource changes in a team, like the skills gaps I mentioned earlier, it can definitely be something where you're building up critical skills, and testing is one of those things where it requires good technical knowledge to do it right, but it also requires a lot of good business knowledge to get it right, and sometimes a lot of analytical ability. So it becomes a thing that requires a very specific skill that if you lose it can be very difficult to train up or take a lot longer. And typically in my experience, you can take 2-3 months to bring a dev up to speed. but you often need about 6 months to bring a tester up to speed because they've got to really learn to master multiple parts of the business to do their job successfully. So resource changes become quite sensitive. Critical defect discovery, again, if you're going to be finding lots of defects, it's going to slow down your automation effort. And so you want to be thinking about, if you want automation to work and you're wondering why automation is not working, sometimes you also got to go all the way back to quality design. Is your software designed for quality, because critical defects are going to slow down your automation work. Growing tech debt, this is a particular bugbear of mine as well. I feel like teams do not do a good job at handling tech debt at all. And I think tech debt in software is often even worse than tech debt in the real world, because it's going to cost you even more in the end. If you're not maintaining your software, if you're not keeping it up to date, moving on to new libraries, moving on to new patches, as you're moving software, you're taking your like test automation and updating it in sync with those software changes. You're just playing catch up all the time, and then you're never going to be able to really get the impact that you can from test automation because you're always playing catch up. So you've got to deal with the tech debt as the change happens. Do the automation change at the same time. Don't let it build up. And then I know in technical dependencies, those things happen as well. Sometimes we're working on things, we think it's going to work a certain way. It doesn't always turn out that way. But yeah, I think, in summary, if we want to build quality software, we really need to be thinking a lot about how we're designing our software and our approach to designing software. Where we want to do is rather than focusing on the bigger picture, we want to focus on the small individual modules and functions and APIs and microservices that make up our bigger applications, and rather focus on testing those properly, designing those properly, and getting that right. And once we can do that right, it makes it a lot easier for us to then focus on how do we now take that and automate it more effectively. Again, automation in small chunks is a lot easier to maintain, a lot faster to write, and allows us to be able to achieve high quality software, to be able to deliver it fast if we can do it correctly. Cool, thank you. Looking forward to any questions.
Excellent talk. Thank you so much. I've thoroughly enjoyed it, and I'm sure that the audience has as well. Before we get into all the questions, I actually have a question of my own.
Okay.
And I talk to a lot of people who stress the importance of testing like you do. Mm-hmm. And they often mention things like, as you mentioned in the previous slide, my team's changing a lot, or we're growing a lot, but also my boss or my management, they don't understand the importance of spending more time on testing. So what would you say, or what would your advice be to make it clear to a manager or someone upstairs that testing is extremely important? Is it showing what can happen if you don't do testing, or that may be a little confrontational, but what would your advice be?
Yeah, and that's a good question, because the irony is, the better that you do in terms of testing your software and producing quality software, the less management actually takes interest in it. When you've got buggy software that's falling all over the place, management's going to know we need to get testers in, we need to build high quality software. When things are working, managers tend to think, we don't really need it. Things aren't really going wrong. And that's when managers then start to compromise and often have those conversations of, we don't really need our testers. And so I think that's almost one of those things where if you're doing a good job as a tester, you're almost running into that space where you're almost running yourself out of a job, because now management's doubting, do they really need the testers? Because we never really hear about it too much. Things just seem to be working. And that's the value of a good tester, is that they can make things work. But I think it's just that reminder of trying to go in, and you've got to work with your managers, I think, to understand what testing does. And I think it's a good thing that you mentioned. I think a lot of managers don't actually understand what testing is. They think testing is purely just validating what the dev's done. But I think good testing is a lot deeper than that. It's someone who asks the right questions, someone who gets involved at the very beginning of a project, looking at the requirements phase, asking questions of the requirements. Are we building our software right? Are we building it with testability in mind, and not at the end when they're only getting the software for the first time once it's been deployed into some test environment and now they're playing with it. They should be involved early on in those discussions. And I think you like really start to understand the best value of a tester when you put a tester in that space where they are playing really early on and they're getting involved and having those discussions, and they're actually working with the devs to say, hang on, if you write your unit test this way, you can cover more things, and you can write 50 more unit tests. I can help you write those unit tests, but if we tackle it there, we don't need it later on. And it's something where you can play the value in terms of your team should start vouching for, we need the tester, because they're so valuable to make my life easier. And I think that's probably the easiest way, or the best way to do it, is to try and make that change in the team, so that even if your manager says, I don't think we need testers anymore, your team's going, no, but we do. So it's making sure that your tester is actually playing that difference and the whole team feels it. If you're working only at the end and you're only starting to test software once everyone's thrown it over to you, they might not understand what testing entails. But if you get involved early, they definitely see that.
So get involved, get the support from the team, and make it clear how essential it is.
Yes.
Yeah, perfect. All right, I'll hand it over to you, Derek, for the other questions.
Yeah, cool. Thanks, Craig. That was pretty awesome. Okay, so we've got quite a few questions. I'm just going to read them out, and then you can answer them from there. The first one is quite a popular one. So Joris asked, when you compare unit testing between Mendix and more traditional development platforms such as Java or C#, what counts as a unit differs a lot. Unit test could cover a single method or class in the latter, while the smallest testable unit in Mendix is a microflow, which is usually a lot bigger. What are your thoughts on how, or if, this influences the whole push test as far down the testing pyramid as possible idea?
Good question. And I think that is a common problem, I think, particularly with a lot of low-code solutions, just in general, in that you might get some sort of things where, because you don't have, or you like don't own your own code base, you sometimes can't go into all the details of what a unit test would do. So typically a unit test can hit really the smallest function of the code. If you're dealing with something where there might be a microflow and there's a lot of underlying stuff, you can't necessarily always control that. But I think whatever you need to do, you need to break it down into the smallest piece that you can control. And so if you've got the microflows, then you can sort of make sure that each microflow is tested as, as accurately as possible. Another thing which I advise, and we do some low code stuff at Alan Gray as well, but what we do is our really complex logic, we still write APIs for. So we still put anything that's really complicated where we feel like it needs to be really well tested, and we want to test it as aggressively as possible in unit tests, we actually decide to then write APIs for that. So even though we have a low code solution, it will call an API to do something because we feel like that's too critical to just put into a flow. And then we will write our test around that. But it's a good question. That's not easy for each individual type of software architecture to be broken down in small chunks.
And I think as far as Mendix goes, microflows are kind of your base level of functionality. So definitely, you would definitely test on the microflow level. However, I do think what you say now puts a focus on avoiding these kind of massive microflows that might develop. Those with multiple logic paths are going to be really hard to test. To bring those back down to smaller chunks of unit of logic as far as possible, I think is the way to facilitate good quality, as your talk has mentioned.
Yep.
All right, cool. The next one, Craig, you said you don't want to use a specific commercial tooling for automated testing. What tooling would you prefer for Mendix?
So, I mean, with Mendix, I think Mendix is, does have some tools that can work with it. I'm aware that Mendix has its own proprietary tool that you can work in. To me, it's really less about the tool and more about the framework and the way you go about writing the framework. So whether you're using that, whether you're going to use something like Cypress or Appium or Selenium, I think they all have their values and they can all solve a lot of problems. But the biggest thing is actually the framework that you're building underneath it. And so what I like to do is I like to spend a lot of effort on building a framework that's quite modular. There's a lot of functions that rather than relying on, say, for instance, a tool's got a function that does this and it makes it a lot easier because it does all these things for you. I don't want to become reliant on the tool. I would rather put an effort to write that function myself that can do the same thing that the tool's doing, just because I don't want to rely on the tool because it's built into the tool. And so I would still use the tool for identifying objects, for asserting objects, for being able to sometimes feed and interact with certain objects, but I wouldn't want to use a tool for all the other features that it can bring you. Now they will obviously tell you different, and that's fine. It's their job to kind of sell the tool to you, but then you're going to tie yourself into the tool, and if you're going to have to now take yourself out of it, you're going to be stuck with a tool, and all your testing is built around the features that they've got. You're not going to be able to make a move. If you're using an open source tool, that's sometimes not too much of an issue. If you're using a commercially licensed tool, that's going to be a very expensive thing to now move off.
So I mean, as an example, you guys wrap your tool in, I think, in Java or just a standard language like that, right?
Yes.
So I mean,
yeah, we use one programming language across it, and whether our code is written in Scala, Golang, we've got Python code, we've got JavaScript code, we've got React, we've got a variety of different things, but we just, from a testing perspective, every single test uses the same framework. So we've got one framework for testing. It all uses the same language. Every test behaves the same way, whether I'm testing at an API, whether I'm testing at a UI level. We use the same language and a similar framework across the teams.
Yeah, so basically when you run your tool, I mean, you call the Java methods that call it, they stay static, but then just the underlying tool that those libraries reference, then that enables you to pull it out. So in the same way, you could, if you wanted to, you could write that logic in Mendix and reference those library, whatever tool library points in Java itself as well, if you wanted to, or you could write it like as a parallel testing architecture to test the Mendix. Would be
Absolutely.
The same way.
I think it's really, like it's less relevant on which tool you use and more the framework that you build. And, Mendix is perfectly fine for building that framework.
Yep. Cool. All right. Roy asks, what can a developer do to help out the testers? I think he says later in terms of building. I think it's one question.
Okay. Well, I think that's a good question. And I think the devs can really ask, get the testers involved by, I think, asking the question of, what's important to you when I'm working on this particular piece of function? So I'm working on this function, what needs to be tested? As a tester, what's important to you? What are you thinking? What scenarios are you thinking? And actually, start engaging the tester to say, what scenarios should I be thinking about when I'm testing? And then, you can either bring them into your unit test and then they can help you to say, well, add this permutation. And I know what it's like to be a dev. Like I said, you'll write minimum passing tests so that it passes your pipeline you can throw it over. But often there's 50 other tests that you could have thought about, but you didn't. Rather try and build that into your unit tests. And even if your tester's not capable of writing those unit tests, if they can at least help you identify them, you can put them together. But I think it's really bringing the tester into your space. Don't kind of, again, just wait until, okay, it's now ready for the tester. Bring them into your space and say, I want to build this right. And I think another question that is testability. From an automation perspective, like I spoke about breaking things down into small chunks, if you've got modules that are too tightly wrapped around each other, that makes testing complex. You want to break down your functions as simple as possible and rather have a lot of very easy functions than one function that does multiple things. And so you want to be able to think about that and think about the testability of your software. And a good question for yourself as a dev to ask is, how do I go about automating this myself? And if it sounds too complicated to automate, it's probably too complicated to build. Come up with a different solution.
All right, cool. The next question, so there are low-code applications developed which have a short lifetime, maximum of 3 to 6 months. An example is a COVID-19 related application. So looking at the return on investment, in any way, does it make sense to start up the whole test automation setup? It does not reach the break-even level, but maybe we have to look at the quality it brings.
And that's a good question. And I think test automation in particular, I think, is a long-term game. You're not going to get a return on investment in a short space of time because it takes a lot of effort to build a good automation framework. Just as it takes to build software, you've got to spend a lot of code to be able to build a good framework for automation. And so I wouldn't go down the path of doing everything. I think if your life cycle really only intending on lasting 3 to 6 months, you can definitely go down that path. What you're going to be very, very careful of, as I think most people that design these COVID-19 apps, is it's been a year and we're still using them. So you've got to be very careful in knowing that it's definitely going to just be those 3 to 6 months. And if there's that slightest inclination of we might need this for longer, that's something to look into. But again, if you're thinking about the design of your software modularly, you can still write your code in a certain way that even from a unit testing perspective becomes easier, there's a lot that you can do to save that automation effort down the line.
Yeah, I mean, to your point about technical debt, Craig, I think that, I mean, 3 to 6 months does sound good, but if the application is useful, it's going to be around much longer. And then you shipped a lot of technical debt in there already. And
exactly.
you know, yeah, like you said, it's hard to pull that out.
I mean, how many of us really still use temporary apps, right?
Yeah.
Exactly.
Well, we'll change it later.
Yeah.
Whenever that is.
Yeah, just look at all the Excel files everybody uses. Same thing. All right. So how do you measure quality?
Good question. I think quality is difficult to measure. I think one of the easy ways to measure quality is defect leakage. So that's essentially what are you missing? And so what I mean by defect leakage is what goes into production that gets logged. So you can look at your production counts, but it's also a little bit further than that, where and this is where I look at it. I'm like, when the code is finally done and the dev says he's done with it, it's what happens thereafter. So if you say you're done, but the code is still failing later in the line by some BA playing with it or something, that's defect leakage. Get in, investigate it. And so I would measure on trying to bring that down. But I would also say that good quality can be measured in multiple ways. Really good quality actually saves the business. Where it does save the business's money is on customer support. You should be spending less money on customer support because your software does what it's supposed to first time in the way it's intended. I think good quality software, is something that should be delivered fast. And I think you should see that where if you should be able to go from delivering software, let's say once every 2 weeks you're deploying, to a point where you can deploy every single day, but your production defects are not going up. But it is a difficult thing to measure. One thing I will say is you can't measure software quality by the number of defects your testers find, because again, that's a superfluous thing, especially considering that a job of a tester is not to find defects, but to avoid defects and mitigate defects. So you should actually want your testers to not find defects. So that's not something I would use. I would try and rather measure what you're missing and then look at the other sort of side effects of, can we actually deliver faster without creating noise in production?
All right, cool. The follow-up question then is, what is enough quality?
Look at that triangle that I mentioned at the start. The more you're going to spend trying to go into quality, the longer it's going to take you, the more it's going to cost. Enough is really dependent on what the application does. When I worked for Amazon, because I worked for Amazon before I worked for Alan Gray, Amazon had this, they're really gung-ho. They will deploy anything into production, and a lot of it breaks. And it was actually quite scary, the stuff that went into production. And as a tester, I used to get really upset. I'm like, why is this even going in? I had to make quite a few changes in my team because I didn't want that to happen. But the reason why they're doing that is they've created this thing of, we're going to be innovative and our clients are going to understand it in the cloud space. So we're going to go and deliver it. And so they go in and they will create new cloud tools that do 90% of the job, but the other 10% falls over all the time. But they fix it on the spot. And that's part of what they do. But if you use Amazon and you go to their login page and their payment page, it still looks like it did 20 years ago. Why? Because it is still the same stuff that worked. And so for them, they've gotten to the point where this does its job. It doesn't need to be done any better. They've reached a point where this is enough quality for that particular piece of functionality. And that's something where they're not going to compromise on. They will make sure if they're going to change anything on the login side and anything on the payment side, they're going to test it to death. And so I think it's also what you're testing, what the nature of your application is. At Alan Gray, we're dealing with people's money. We've got to be very thorough with things. We might be less thorough with the UI. And if we put something online and maybe some image on the screen is not quite rendered correctly, we don't want that. We'll definitely try and fix it, but we're not going to compromise on something that has to work. And so it really depends on what you're testing. Some things have got to have high quality. Some things you can maybe afford to experiment with.
So it's a calculated risk, basically.
Yeah, calculated risk. Yeah, it's got to do with the impact of what if it goes wrong. What's the impact? And if that impact is catastrophic, rather test a little bit more if you can.
Yeah, cool. All right. The next question, I think it might be a similar answer, but given the possible complexity of microflows and mostly handling entire objects with these, what would define a sufficient test set?
So you need to have each microflow and I guess each sort of object that ties into it. You want to test that quite well. So again, if you're thinking of a microflow, what are the different sort of inputs that can come into this microflow? What does it need to do and what are its outputs? You want to try and break it down into as simple things as that, and you want to be able to really automate that or test that as thoroughly as possible. You will still need to go further up the triangle. So I'm not saying that you're not going to do some integration tests. I'm not saying you're not going to take all the microflows and work them together. But when you do, your permutation count is now coming a lot less. So whereas you might have been hitting 100 tests through your entire operation, you might actually only need 5 or 10 to make sure that they're all speaking to each other, because you've handled all the other negative scenarios in each of them. And so whether you're hitting a negative scenario end to end to see what happens here, that's only going to fail down here, why don't you just take that last sort of function and hit the failure there and see if it operates properly? This ain't going to work further up the chain.
That's a good point. The next question is, so quality by design also requires testability by design?
Yes, absolutely. I think that's interchangeable, and that's again how we need to be thinking about it. When we're designing software, we've got to ask ourselves, how's it going to be tested? And I think that's something which I take quite seriously, and I work with a lot of other architects in my company to make sure that when we're designing something, we're asking the question of how is it going to be tested. And again, if the answer is too complicated, we need to go back to the drawing board. We're not going to design software that's complicated to test. We'd rather just not build it. We built it the wrong way.
All right, that's a good point. Craig, what do you think about mocking, using fakers, etc.?
Yep, I have nothing wrong with mocking. I think mocking can work well. There was a slide that I mentioned earlier about testing independently, where you've got to know your specifications quite well. And I think that's what you need to just do. I think mocking can work well, but you need to know what to mock. And I think too often, because mocking really does what you tell it to do. And so if, I think mocking can work well, but you need to understand all those permutations of what it will need to respond and how it should respond. I've seen so many times where people go into these details and they put a lot of mocks together, and then something fails on the very first integration test because their mock design was wrong. You've wasted a lot of effort. So you really got to understand, okay, well, if I'm going to design this mock, I've got to actually understand, what is the mock supposed to look like? What does this underlying service actually look like? How does it actually function and operate? And then design my mock accordingly.
All right. There's some more questions coming in.
That's good.
So that's pretty cool. All right. Do you have an approach for testing Mendix applications and how the architecture should be to enable effective test automation?
So again, I don't work with Mendix on a day-to-day basis, but in my experience and seeing what Mendix is capable of, and I think Mendix is quite a powerful sort of tool in terms of being able to deliver things quickly. Again, I think it's just a matter of breaking it down into as small chunks as possible, and rather thinking of the bigger end-to-end application, thinking about it architecturally from every little part and how it works together.
I think one of the things you said earlier was actually quite valuable around testing where the logic is, or testing where the logic lies. So obviously with your test with the Mendix applications, there's various layers of, I would say, logic where microflows invoke logic. Sometimes logic will just be around navigation or just some validations or things like that. But other times you've actually a core business logic. And so obviously, I think what you said earlier applies to that. If you're going to run with test automation, then try and test those elements, those very complex elements, or those very important elements sooner rather than later. Then obviously the second thing I think is, the neater you create your modules and where your logic lies and that comply with those various standards, naming standards and those type of things, I think that ultimately does lend itself towards automation in the sense of knowing where you're going to test certain things and why. So
I mean, and I know with Mendix as well, it's just low code solution and you're building these microflows and sometimes there's objects. What you've got to be very careful of as devs is they've got to make sure that each individual microflow again follows that sort of naming convention. So when you're automating and you're calling something, you should know exactly what you're calling. I've seen some low code solutions where they hide everything behind this sort of self-generated API, and so when it generates this UI at you, this button don't necessarily have independent identifiers, you can't automate that. And so you shouldn't build your software that way. But I know Mendix allows you to be able to build those, the sort of independent things. You just got to make sure that you do build that where everything can be referenced independently.
Yeah. How do you switch? Which scenarios you need to test? I'm not sure.
How do you know which scenarios you need to test?
I think that's perhaps it. You don't know if you miss maybe scenarios right. How do you deal with it?
Well, so like when you're dealing with code coverage, it's easy because you can get tools that can measure that for you. But you can have 100% code coverage and things still go wrong because you've missed business scenarios, you've missed other sort of logic things, and that's difficult. That's a difficult thing to solve because a lot of that comes with with domain knowledge. You really got to understand your system well, and you're going to have times when, especially when you're new and you don't understand how something works, where you're going to realize something should have been tested and it wasn't. For me, what's important is root cause analysis. So what we do in my company is when we do get something wrong, we have a root cause analysis where we come together as a team and we look at why did we miss it collectively as a team. So again, I never blame the tester. I don't blame the dev. As a team, what went wrong? Why did it go wrong? Why did we miss it collectively? Because someone in the team, in theory, should have had the domain knowledge to have identified. It doesn't happen all the time, but you kind of hope so. And then we start digging into those things. And once we've done the root cause analysis of why this went wrong, we then come up with what's the mitigating action to fix that. And then we put that into place. So it's just one of those things where you're going to make mistakes, you might miss things. And that's okay. Provided it's nothing major and obvious, that's okay. What you don't want to do is make that mistake again. You should have learned from it the first time.
Yeah, cool. All right. I think we got one more. I'm just reading it here quickly. I think it's more of a statement than a question. So I think we can read it out and perhaps hear your thoughts, Craig, and then we can end after that. So this is my general issue with unit tests in Mendix. When I have all the expected outcomes defined, is it then not better to build the flow robust than building special tests around it?
I think that's a good point. And again, I would say that, if you feel like your flow needs to be a little bit more robust, I would say something that's testable is robust. So if you can go through and something can be easily testable and automatable, that should be robust enough for you. I do think that there is sometimes an argument for trying to then build things. Maybe you don't want to use it from a microflow perspective, and you want to be able to build things in a little bit more of a robust manner. Then you build it in that manner. But if it's not going to work from a testing perspective, then it doesn't make a difference if it's robust or not. It's not really robust if it's not going to be able to pass its tests.
Yeah, cool. Okay, well, that's a good point, and that brings us to the end of all the questions, and therefore the end of this talk. So thank you, Craig, once again for your input. I found it extremely valuable. We're definitely going to look to implement some of the things you're saying, and I'm probably going to drop a few questions your way. Jan, thanks for helping us and organizing the event tonight. We appreciate it. And
absolutely.
That's it, I think.
No problem.
Yeah, thank you all for joining. And special announcement, on April 6th, Johan den Haan will be streaming a 1-hour live session about Mendix 9. So next week on Tuesday, make sure you tune in, 5 p.m. Dutch time. We'll be sending out more invitations to you. And if you have any questions about Mendix 9 for Johan, be sure that you join the session and ask your questions there. So I hope to see you there next week. Thank you, Derek. Thank you, Craig. And see you all next time.
Cheers.
Cheers. Thanks.